Hello, in this video I will show how to calculate a U-value for a ground supported floor with underfloor heating. In this floor here we have a part where we have underfloor heating and we have a part of the floor where we have without underfloor heating. We actually don't combine these two, but we calculate the U-value for the part with underfloor heating, and then we have another calculation where we calculate without underfloor heating. So now we're just looking at this part here. And down here I made a detail of the construction. And over here we have the part where we have underfloor heating, and we actually calculate for the underfloor heating pipes and down for the U-value, because that's where we have the heat source, and that means that we won't start with RSI, the internal surface resistance, but we start in the material. And then we have the partition foundation here where we don't have so much insulation, so we calculate also from in the material and down U2. I've written up here the construction, so we have actually tiles on top, then we have a screed to even the floor out, and then we have a concrete layer of 100 millimeters, but we calculate from the heating pipes, and they're placed 2/3 down in the concrete to make sure that the heat can spread out, so we won't have any places where we don't have heat. Then we have 200 millimeters of insulation, and then we have 200 millimeters of light clinker, a capillary breaking layer. And the foundation, partition foundation, that is made out of 2 light clinker blocks. So that's what we have. But first we're going to calculate U1. So we go to you can see I have actually cheated a little bit. So I have written the material in, and I also put the sketch over here. So we start from the top and we're going downwards through the floor. But the thing is that we don't have RSI as we're starting inside the construction. We start from here, from where we have the heating pipes. And that is 2/3 down they start. And the concrete slab is 100 millimeters thick, so that would be 33 millimeters down, so that would be 0.033. And then we need to find what is the lambda value for that, and that we need to look up in DS 418. So we go to DS 418. And then we'll go to Annex F, which was at page 80. And then we have to go about concrete. And here. And then this concrete that is reinforced. So we need to look down here under the graph where we have here external and internal lambda value, and we are internal, so the lambda value will be 2.44. So we go back and we write 2.44, and that gives us a resistance of 0.014. Then we have the insulation, and we had 200 millimeters of insulation, so 0.2, and the lambda value was class 37, so 0.037, and the resistance is then the dimension divided by the lambda, so that would give 5.405. And then we have the capillary breaking layer, which was the light clinker, the Leka nuts we had. And we have to divide that up in 2 layers. We had 200 millimeters, and as a capillary breaking layer, 75 millimeters up is going to be wet. That's where the moist can be sucked up, and then it's dry over there. So we have actually then 200 minus the 75, so that would be 125, so 0.125. And then we need to find what is the lambda value for that. And we can't find that either in DS 418. So I have found a data sheet for these capillary breaking layer knots. So I'll go to there and so you can see that. Also put it out on its learning, so you have it here. And here we can see that we have here 0.09, and that's the lambda value. So that I'll write in. So 0.09, and that gives us a resistance of 1.385. And then we have the wet layer, so where the moist can be sucked up. That would be the rest of the 200, so that 75 millimeters, so 0.075. And it has the same lambda value. It's just that we need to times it by 1.2, and we can see that in DS 418. If I go here, and then I go to table of content 3, page 3, and then I scroll down. And here we have in chapter 722 design values. So we go to page 57. And then down here it says use towards soil the design value of insulation product. There has to be time by a factor of 1.1. So that is what we're going to do. And the reason is that when we get water into a material, then it is much better in conducting heat. So therefore, we raise the lambda value by 1.2. So we times it or multiply it by 1.2. And that gives us a resistance of 0.694. And then we have the resistance against the soil, and that we can also find in DS 418. If we go over here to DS 418 and we go to the table of content, and then we have it here where we have ground supported floors, basement floors, and basement walls against soil. So 37. And here we have this table here. So it says ground supported floor from 0.5 meter above to 0.5 meters below terrain, it is 1.5. So the resistance is 1.5. So we write that in here. And then we add all the resistance together, and that gives us a total resistance of 8.998. And then the U value is then 1 over 8.998, and that is 0.111. Then in the floor construction, we don't have any air gaps, and we don't have any wall ties. So the total U value will be 0.111. So now we have to calculate U2, and that's for the partition foundation. So that's what we have in here. And down, that's U2. And there we have two light clinker blocks, and they are in height 190. So we have twice of those, so that would be 0.38. And then we have to find the lambda value for these light clinker blocks. So we go to DS418, and I go down to the graphs where I have the lambda values of page 80. And then I have to find the light clinker blocks. And I have them here. And then this one here, that will be curve E, where we have basement wall below terrain. That's the one I will use. Blocks made of light clinker concrete. And then I had the density of this block of 600. So go up here by 600 up to curve E, and then over, and that is 0.29. So I write that in. So 0.29, and that will give me a resistance of 1.31. And then we have the surface resistance for soil, and we just looked that up before, and that was 1.5. And then we add these together, and that is 2.81. And then we have the U value, which is 0.356. And then again, we do not have any air gaps, and we do not have any wall ties. So the total U value for U2, that would be 0.356. So now we have the two U values. Now we have to find what is the liner loss that we have here, psi k, and that we need to look up in DS418. So we go to DS418, and I go to table of content, and then it's under chapter 6.7, where we have foundation under partition walls here. So we go to page 29. And then it's this here. And here we can see in this table that we have concrete. Now we have light clinker concrete. If we have only one block, it's 20 centimeters, but now we have two blocks. So the liner loss will be 0.01. So the psi k. So we write that in here. Psi k will be 0.01 that per meter Kelvin, and that is given in table 673. So now we have the U1, the U2, and the liner loss psi k. So now we need to find the areas. And the areas we can find when we go back to this part here and we look here, up here. So we have A A1. That's main construction. The area A1, that would be the width of 3.415 times the height of the floor, which is 4.22, which gives me an area of 14.41 square meter. And then we have A2, which is the part that we have here. So that would be half of the foundation. So 0.39 divided by 2 times how long it is, and that is 4.22. So that gives an area of 0.822 square meters. And then we have the LK, which is the length of the linear loss, and that is 4.22. So now we just have to put it into the formula that we use for the U values when we are looking at U values for construction with core bridges, where we had the U for the floor, U1 times A1 plus U2 times A2 plus psi k times LK divided by the total area A1 plus A2. So U1, that was 0.111 times A1 14.41 plus 0.356 times the area of U2, which was 0.82 plus psi k, which was 0.21 times the length 4.22 divided by the total area, which was 14.41 plus 0.822, which gives a final U value of 0.12 bat per square meter Kelvin. So this is how you calculate the U value for a floor with underfloor heating. If we have calculated the one without underfloor heating, you just needed to include the top of the construction. So if we can go here. So that means that you just needed to include from all the way up here and down. So then you will have to include this one here. You can try and do that on your own, and then we can talk about it. See you soon. Bye.